All right. Well, introduce yourself too. Hi. I'm Kevin Ford with the High Street Consulting Group. I'm based out of Chicago. I'm basically your data guy today. So they usually like to hire me in the morning before the lunch coma hits in, so I'll try to keep it light. But essentially my job today is just give you a general overview of how we approach the solution, which is a combination of, you'll hear PMDIS today, as well as decision lines. PMDIS is basically the front-end solution of how do you take data from the existing management systems, translate it into actual performance impact analysis, which we can then analyze in decision lines. So I'll go through that overall process. We'll then do a more brief foray into the technical weeds, just give a little bit more transparency about how we came up with the numbers you're going to see in the decision models, hopefully get a little more interaction about, is this the right information to make an appropriate decision? So we're taking an objective approach to evaluating these projects. And then I'll walk through an example of how this works. So in terms of the overall framework, this arrived from the TTP 2040. It's essentially a performance-based plan programming process where you start with identifying what your goals and objectives are, assigning different performance measures that are going to quantify how well we're making progress towards those goals and objectives. We're then going to look at our projects and see how they impact those different performance measures, which will give us a basis for starting to evaluate the projects and prioritize them. In terms of prioritizing, you have to take into account different perspectives across the state, as some regions may value, say, reducing critical safety problems more, others may be focused on achieving state of good repair, economic development, et cetera. And so we use weights to help us understand what those priorities are to give us an appropriate project ranking. Once we have those project rankings, we then evaluate our investment strategies. So how do we go about selecting projects, and what is that overall program projects going to buy us? And then we can start to evaluate the trade-offs to understand the performance implications of different policies. Now, the performance measures we used to evaluate the decision, we typically will just refer to them more generally as criteria. Criteria meaning that they could be more subjective in nature. It's just basically what we're going to use to assess how well is a project performing. And we typically align this back to the goals. So the top of each of these tables are hopefully are familiar to most of you. These came from the original TXDOT strategic plan. So essentially what we're trying to do is focus on evaluating projects for how well do they improve safety, achieve a state of good repair, or preserve the system. Obviously we want to protect the environment, grow the economy, reduce congestion in urban areas, as well as improve reliability, and enhance connectivity more for those non-MPO types of regions. And Eric.
Yeah, I just wanted to let everyone know, in the blue package that you have, this slide, I think the next two slides are in there printed out, because some of this is pretty small. For those people on the phone, the presentation is available for you to download from the community site, as well as the folder. But the printouts are in the printout as well.
Okay. Thank you. So I guess as you look through the criteria, essentially on the safety side, we're looking at how do we reduce crashes, focusing primarily on the higher severity crashes, fatal and serious injuries, as well as overall, as well as the crash rates. On the preservation side, we're looking at reducing those poor assets, both bridges and pavements primarily, some of your structurally deficient deck area, your poor lane miles. We're also giving credit to projects that apply preventive maintenance. So that's keeping your assets in a good state of repair, which is more cost-effective in the long run. So we're balancing both that worst first as well as the preventive cost-saving approach. On the environmental side, you'll see that we do have some maturation we're going to have to go through. Right now, this is just a subjective assessment of are you impacting an environmental project or not. You can obviously start to quantify emission savings and other considerations moving forward. We're just trying to get a sense of will it have a benefit towards that goal. On the economic side, these are primarily proxy metrics based on the highway classification. So if you're improving a national highway system, national highway freight network, or some of those other critical facilities, we're going to give you kind of bonus points. So we typically consider those to be more important to the overall economy as well as the energy sector. On the congestion side, here we're looking at reducing congested vehicle miles traveled, that's the VMT. As well as improving intermodal connections and adding new connectivity in terms of new miles between hubs. And then the connectivity side, we'll be looking at things such as improving access and reliability to the transportation network, improving the trunk network, and also, again, improving intermodal and new connectivity. So let me pause there. Are there any questions or clear things you see that you may want to add criteria-wise? Still too early? Okay, we could have that discussion later. All right, to evaluate the criteria, we had to pull from multiple data sources. So each of the data components exists in different systems. The 5 primary systems we're pulling from is we use DCIS, which is basically the hub for the projects and all the costing information. That's through the TPP. We have the CRIS, which is where all the safety information is stored in terms of the crashes, when they occurred, what their severity were, the type of the crash. We have the RHINO, the Roadway Highway Inventory Network, which has information on your traffic volumes, the geometric lane widths and configurations. We have, now we're moving to Pavement Analyst. So there's been a migration from PMIS, which has all your pavement inspection data, so how smooth your pavements, where the distress is, the severity of the distress is across the state. And then we have on the bridge side, a whole bunch of Pontex BIMS we started with. I think it's now in InspecTech. InspecTech has your bridge inspection information, so how well each of your major structural components performing in terms of their adequacy and risk. Using those data, these are the criteria on the right that you can't read, but the data basically goes into the criteria to help you evaluate those projects. Once you've applied the data to the projects, we then apply a scoring process. So again, probably best to look at the handout, but this is using multiple objective decision analysis principles, MODA. For those not familiar with that, essentially what you're doing is you're applying a weight to each of the different performance criteria. The weights add up to 100%. So we assign an initial weight to each of the goal areas. Then underneath each goal area, we apply a second set of weights of, well, how well we're performing towards that goal. The other aspect of MODA, besides the weighting, is how well is the project performing against the performance metric. And we do this on a level playing field, so we use different utility or rating scales. Basically what that allows us to do is to translate each of the impacts onto a 0 to 1 scale that we can readily compare. Because that allows us then to compare, well, what's the benefit of reducing 1 crash versus fixing 1 square foot of bridge versus $1 of economic development. So that's how we add those up. So you combine the weights and the scales and you get an overall score for the project, which allows us to rank them. As I alluded to earlier, there is continued maturity that we've recognized for improving the process. Typically, when we evaluate performance criteria, we look at 2 dimensions. There's the more of the, is it data-driven or judgment-based? So more of an objective or subjective evaluation. Typically, we, as you'll see in the solution, we focus on the data side. We want to give the ground truth of what we're seeing in our information systems, but recognize that there may be intangible benefits that we can't quantify. And so you have the flexibility to add in your own subjective criteria and assign a scale, well, is it a high, medium, or low impact, even if I don't have quantitative information. The other axis that we typically look at is if we are focusing the criteria on the existing conditions or predicted conditions. So existing conditions being we know the extent of the problem that the project's addressing, but we may not know how we're actually improving it. And then the other side, the bottom right, would be the impact side of, well, now we also have to understand how the project's going to address the problem. That's typically what we shoot for. So we're always aiming for trying to quantify the impact of the project using data. So our goal is to get into that upper right quadrant when possible. And then you apply your own expert judgment to make sure that those numbers are making sense and are accurate. In terms of the general approach, again, we're starting with some spatial information. So we have to locate where are your projects. We're then going to conflate that with the different data systems of what are the data systems telling us are going on at that project location. With that information, we then have to translate it into something that allows us to analyze the projects to come up with a performance metric. And so we run through a transformation process so we can quantify, well, how many crashes do we expect to reduce, how much bridge deck area are we improving, and look at how those conditions will change over time. Once you have that analysis done, we then load those into Decision Lens as a rating. And so that's how we come up with the project score. So again, the score is a function of your weight, which tells you how many possible points the project could get. Perfect project will get full points. Projects only get a fraction of points. That would be the value, and that comes to the rating scale. and then you just add up all the weighted values to come up with that overall score. Any questions with that? Yes, sir.
So taking the stat attributes and defining the criteria ratings, that's done outside of decision lines?
So we automatically will generate a set of rating scales for you that's based on the minimum and maximum data points within your project set. And they'll be linearly interpolated in between. So if you have a project that reduces 10 crashes and that's the max, that would get you the full 100% of the points. If a project gets half of that, say 5 crash reductions, you get 0.5 or half the possible points. And then you can adjust those within decision lines. So it's preloaded for you. Yes, sir.
Are you including data from MMS, the maintenance operations logging, or do you have pavement analysts consolidate everything from DCIS and MMS at that point?
Yeah. Ben, I don't think we're using anything from MMS, correct? This is just the payment analyst is directly what we're pulling from?
Right.
Okay.
I mean, payment analyst knows about MMS and DCIS.
Gotcha.
It might just be consolidated for you. I just want to make sure that was included in there.
Okay. Yeah, we'll have to follow up and make sure if there's more direct route to get at the data. But right now, it's just a compilation of the DCS limits with payment analysts. Yes?
If districts go in and update DCIS or the source of the data, does Decision Lens automatically do a live update, or do you have to wait a little bit before we do our portfolio?
Yep, and that's probably also a Ben question, but my understanding of the timeliness of the update of the data is that I guess you want to say it.
DCIS data is updated daily, and all of the other systems are updated annually. We only use complete years of crash data, so even though that is updated on a regular basis, we only update it once a year, and all the other systems are updated officially once a year.
But to more directly answer your question, you would have to re-download the data to Decision Lens in order to get the results that you're looking for once, the DCIS has been updated. So it's not a direct, automatic update.
And you have the option to override before it goes into Decision Lens or after, but it won't be reflected in that original data system. So you want to usually go through the database first so they're aware of the changes you're making.
Can you do an ad hoc update?
I do not believe it's set up to automatically pull more than the host system's been updated, but you can ad hoc override the information yourselves.
It's important to point out that these can also go in on templates and be loaded manually, so that is the way. So, for instance, we do only have crash data annually, but if you're looking at safety projects and you need to update that data, you could not only manually override it, but change that number in the template to upload it. So we have several options for you to be able to use newer data than we have annually. And Ben will talk, Ben, you can speak to that this afternoon, correct?
Sure.
Any other preliminary questions how we go from raw spatial data to scoring? Okay. So after you've scored projects, then you get into what I consider the more fun part, selecting projects. And so this is focusing then on what are the trade-offs of if we fund a certain subset of projects, what does that buy us? And should we be investing more in one type of project or another? And how do you make that decision? And Decision Lens offers various tools for performing that. Overall, this solution is based off of some nationally vetted information. This is actually a report that I authored, NCHRP Report 806. There's an update going on, NCHRP Project 08103, but essentially that's just saying that this has been well researched in the field. Many states are applying.
Kick it a little bit.
Oh, yeah.
Kick it on, it's hard to hear back there.
Yeah, you got the fancy fan, too. This is a lucky one. Okay. This is just saying that there's national research that goes through if you want to get into how do you do multiple objective decision analysis or the implications. You can certainly look into these resources, and the way it's, again, the framework is quantifying performance impacts, which we talked about in PMDIS. How do you scale, weight, prioritize projects, and then select them. All right. With that, I'll go now through more of the technical components of how we came up with the scores in the system, those raw project ratings. So the way the solution works is, well, first we have to determine what is the scope of work associated with the project's upload to Decision Lens. So this is a bit of a, we're trying to read your minds here based on what information you put into the system. So we're reading through the various descriptions and project classifications to infer of, are you doing pavement work? Is there a safety component? Is it a winding project? So we're using various text recognition technologies to look for different keywords. So if we see pavement in there, we know, well, let's look to see if there are any poor pavements, and then we'll analyze it. If we don't see it, we don't assign the benefit. You may have to upload yourselves or get a little bit more clarification on what are those right phrases we need to be putting into our project descriptions. Questions on that?
So important, I may add for the folks that are in the district and us, or if you just update DCIs in general, stay consistent. You know, and everybody knows that, but everybody does it, things a little, because, you know, there's very few edits in DCI, well, any edits in DCIS for that matter. So people tend to put in their own, spin on what one word means or abbreviations and various abbreviations. Going forward, once we get whatever tool or whatever system we end up with, more than likely there'll be some consistency there. But for now, we have to deal with that. It is what it is, so.
Just putting in the words doesn't guarantee you the points. It just means we're going to go look for that data to analyze it. But we try to be careful and look at every possible abbreviation, misspelling, based on we've analyzed thousands of projects that have been submitted in the past to come up with that initial list. So you can see payments been spelled like 10 different ways. So we're looking for all those different phrases to clue us in on, do we need to evaluate this performance area? Once we've determined if we need to look at a certain performance area, now we have to analyze the underlying site conditions. So we're looking at basically two types of predictions. The first is what we call the no build, of what would happen if we don't fund the project over time in terms of that performance. And then we look at how is the project going to impact that no build state. So that's giving us, if we fund it, now what's our new condition. If you take the difference between those two, that's the overall benefit or that build state. So I'll walk through each of the performance areas. I'll try to get too far in the weeds, but I just want to give you a general overview. So first, we're going to start with safety. Has anyone here evaluated safety benefits before, or have used that highway safety manual? Okay, so I'll go fast. With the highway safety manual, basically the best practice is you apply safety performance functions to tell you what's the likely number of crashes at a location. You then apply a multiplier, which is called a crash modification factor. Multiplier says that if I add a rumble strip or widen a shoulder, I'll likely modify that likely number of crashes by a certain percentage. So maybe I'm getting a 10% reduction in crashes if I apply this countermeasure. And so we applied some math to look at what the crashes would be expected with and without that countermeasure being applied. So we grow crashes over time based on vehicle miles traveled. And then we apply the CMF to determine if a benefit is going to be associated with the countermeasure or not. And this is all based off for the PMDIS, is we're looking at historical crashes. So we're looking at your most recent 5-year history at a project location, look at the average annual number of crashes we've seen, and then we'll apply the CMF to get to the benefit. I think I spoiled my punchline here. But again, 5 years projects, apply CMF, the change in the number of crashes, and then this is what the CMFs look like. Typically, you may see it broken down by CAPCO. I think they're replacing the scale moving forward, but that'd be your fatal, serious injury, possible injury, property damage only. They sometimes have separate multipliers. We use specific TXDOT crash modification factors from your safety division to be consistent. And then on the vertical there, all the different types of countermeasures, whether it be a grade separation, your reconstructed interchange, auxiliary lanes, et cetera. And each of those countermeasures have their own multiplier that determine the change in the safety crashes. This is just where the data comes from. So I think it's in your handout. So you'll see the different data systems, the specific field of the data systems. More of the story is there's a lot we're pulling. But at the end of the day, we're trying to calculate the criteria from those multiple data fields. I mentioned societal cost savings that you'll see in the model. That is a way to try to monetize the benefits of a crash. I mean, obviously, it can't cover pay and suffering, you can't put an obvious value on human life, but you can quantify the economic impact of the property damage, legal fees, et cetera. And so there's a respective number to say a fatal crash will typically cost, I think it's about $10 million. Serious injuries, I think a couple million, and that goes down the scale. But the societal cost savings is one way of looking at those crash savings. So you'll see that metric in decision lines today. Other than total crashes, there's also crash rates. This is just divided by 100 million BMT. The other aspects to safety is recognize that projects may not always reduce crashes, but they're preventing possible crashes moving forward. To help start to address this, we're also giving points based on, well, first, is it improving a hurricane evacuation route? So if we keep those routes safe, the shoulders widened for folks to escape in the event of a hurricane or other event, we would give you additional bonus points for those types of projects. And then just a general safety project classification. So if the project classification tells us it's improving safety, you're just going to get some baseline points for that as well. Are there any questions on the safety side? Okay. Preservation. On the preservation side, typically the best practice here are there are predictive models that look at how various distress indices will change over time. So as the asset ages, typically the deterioration will increase over time, starts to accelerate. So we're using these models to understand how your payments and bridges will change over time at each project location. And then the projects themselves will typically have either a, what we call a performance jump, which would be you're just jumping up the curve. So say I'm going to do a bridge rehabilitation, I may go from a condition rating 5 to a 7. 5 being a fair state repair, 7 being a good state repair. Replacements would give you an obvious reset back to kind of perfect conditions. The other aspect is reduced rates of deterioration. I mean, we may not get an immediate impact in that distress, but it's going to make the deterioration slow down over time. And so we're, again, looking at the scopes of work, determining what is the right benefit. Is it reducing rates of deterioration? Is it a performance jump? We're applying that to our deterioration models, and we'll add that up for all the bridges and pavements within your project limits, either in a poor or good state of repair at the timing of your project. On the bridge side, this one, another one I wrote with NCGP Report 713, which looks at how you estimate highway asset life expectancy. And so we did in that study is it outlined an approach that was built into the new PONTIS, the Ashtabula Bridge BRM. And what that approach does is essentially looking at what is the likely deterioration over time, given the bridge's current predominant material type, age, condition rating, and traffic volumes. And so what these are doing is it's using, in our case, we looked at 24 years of Texas bridge inspection data for over 53,000 structures. We fit time non-homogeneous Markov chains, which is just saying what is the likely rate of deterioration given that bridge's age, component type, if it's steel, concrete, et cetera. We apply that to each of the structures within the project limits, assume the most likely deterioration path, and then if we determine that a bridge work is going to be done and there's likely to be a poor bridge at the time of the project, we're going to assume you're going to correct that poor bridge and you're going to get a benefit, and that'll be scored in decision lines. Questions on that? Do we have any bridge pavement engineers in the room? Man, my job's easy today. All right. Payment side, this again we coordinated with TXDOT folks, Magdy's division, and MNT. They use time homogeneous Markov chain, so constant rate deterioration over time. So we're just looking at different, whether it's asphalt or concrete. We have predictive models for both the ride, which is the smoothness of the roadway, and the structural stresses of the cracking, rutting, bleeding, faulting, those types of indices. We predict those out over time. And again, we're looking at where is your project located? Are you doing pavement work? What will be the likely distress and smoothness rating at that time? Will the project have a performance jump, reduced rate of deterioration? And that determines if we assign a benefit to your pavement score. Flow-wise, lots of data fields. DCIS, you can see we pull type of work. We have to look at the beginning and ending mile points to determine where the project's located, the control section. For BMIS, we're looking at the deck, super, sub, culverts, each of those major structural components, the visual inspection rate and the 0 to 9 scale if they're assigned. We also look at information, the structural deck length, deck width to get that deck area. Payment side, very similar. Same information from DCIS of looking at the project, but we're looking at the ride score, the distress score, how many through lanes are there, the width of the pavement. I assume any questions on the preservation? Okay. I'll just keep moving. More time for lunch. Jared's feeling generous. On the congestion side, so this is where we're starting to look at the delay savings. So typically when we talk about congestion, there's two types of components. There's just the general magnitude and delay, so your travel time savings. There's also the reliability of how confident are you you're going to be able to get from point A to point B. For the PMDIS, we focus primarily on that former one, the travel time savings, although you can certainly use the NPMRDS or other travel time databases to get at the reliability. In terms of the travel time savings, we're looking at, from the time of building the project, what would be the likely change in either the capacity or effective capacity of the roadway. We look 20 years out to see as traffic volumes grow, how does that benefit accumulate over time. So it's 20 years of congested VMT reductions is essentially what we're looking at. When you're analyzing congestion, this may vary based on the time frame of when you're looking at the project. So we recognize that if you're those shorter term projects, those first 4 years, you probably have already done feasibility assessments, you've ran travel demand models, done more comprehensive analysis. What we're focused on is really those years 5 to 10. So getting a better sense of those ones that aren't maybe clearly defined or fully studied yet. How do we sort of get a general sense of how they're going to perform against congestion? So instead of applying a full travel demand model or micro simulation, your synchros, your VISMs, anyone that knows those technologies, we're looking at a quicker approach. So we're applying what I would call TDM principles, which is when you're assigning traffic in those models, it's typically looking at your volume to capacity ratio. So the more volume you have at lower capacities, the more congested you are, the slower traffic is going to go. So when you make a decision, you're typically trying to go for the lowest travel time route as possible. So we're stealing that same type of formula for our analysis, and so that's what the formula at the bottom is. So if you add capacity, you're likely going to have less congestion, you'll be able to move faster, and we can translate that into delay and travel time savings. Now that applies for what's a capacity addition type of project. When it's not a capacity addition project, we will just assume multipliers. So this is based off some historical information of what we've observed, and that would be maybe you're doing ITS, ramp reconfigurations, adding frontage roads, et cetera. So if you're not just adding a lane, there's still a congestion benefit from these alternate project types, and so this would be the effective reduction in the delay savings. We're only focused on level of service D or worse. The definition level of service is from the Highway Capacity Manual. If your volume to capacity ratio is above 0.75, we're going to consider you congested, and then you'll get a benefit if you're able to reduce that congestion. That applies to both controlled access and non-controlled access facilities. So basically your freeways versus signal control. We have separate multipliers for those cases. In terms of the performance metric itself, these are the calculations. So we have it broken down by controlled, non-controlled access, as well as truck and non-truck. There are two types of indices built in. There's the overall benefit, which would be your average daily either truck or daily traffic, multiplied by the number of miles. That gives you your VMT. And then we look at the delay savings. So that's congestion VMT reduction overall. That's your BCI. On the NCI, this normalized one, we just basically divide by the number of lanes to get it more effective if you're not just giving higher points to larger facilities. questions on that? Okay. More data fields, primarily using Rhino for assessing congestion. That's where the current overall traffic and truck traffic volumes are stored, as well as our forecasted volumes in the design year, as well as the number of lanes. In addition to those different congestion VMT saving metrics, we also look to see, is the project improving an intermodal connector? So get more kind of bonus points if the segment is touching an intermodal facility. And then for new construction, again, there are probably possible ways to mature these metrics, but we're just looking at how many lane miles you're adding to the system in the hope that you're improving connectivity. So that'd be more your greenfield kind of designs.
How do you capture the
So how do we capture?
if it's intermodal?
Intermodal. There's a field in, is it Rhino, Ben, where we have an indicator for that?
I think so.
Yeah.
Oh, okay.
Yeah. Yep. So the question was how we determine if a project is improving an intermodal connector, and basically we're relying on the Rhino data field, which has a binary yes/no indicator. And so if we find a yes within the project limits, we assign the benefits associated with that criteria. So those congestion metrics we calculate for all MPO, or projects within MPO boundaries. For the non-MPOs, we recognize that congestion may not mean the same thing. And so for the non-MPO areas, we're primarily looking at a subjective assessment of, does the project improve access and reliability? So this is a new metric which relies on your opinion of, I think it's a yes/no, although we could potentially improve that moving forward. And that'll give points based off the project's improving the trunk system, again, intermodal connector, if it's new construction for new connectivity. So we just divide the non-MPO and MPO regions up so that you're not scoring on the same scale, because it's not really a fair comparison. So whenever you break it out, you're able to compare just against your peer projects. So I assume any questions on connectivity, congestion? On the economic side, so here we're primarily looking at the importance of the project or the criticality of the roadway segment that you're improving. So we're looking at specifically the national highway system as well as the national highway freight network. So if you have a roadway segment within the project limits that's on either network, you'll get the full points for that metric. And then in terms of the system usage, we're looking at the current average daily traffic, base percent trucks, if it's improving an energy sector route or not. Last performance area is on the environment. Again, this one, quite simple, just based on, are you getting CMAQ money, or is there a project classification that informs us that you're reducing hazardous paint, mitigating erosion, or have other metrics. So these last two, you can probably tell, may not be the most mature in terms of quantitative criteria, so you can certainly import your own metrics and ratings. Sometimes I've seen states run TREDIS for economic impact, MOVE for environmental, or a post-process man modeling run. You can see it's an attainment, non-attainment zone. So there's certainly options if you want to build on those areas. But for our purposes, we just wanted to make you aware that, yes, this project may improve the environment or economy, and you can adjust how much it does so. Questions on that? Okay. So now we're going to do a deep dive example on one specific criteria. I think we're focusing on safety here. So I'll walk through how we can score an example project. So for our purposes, let's consider that we are looking at upgrading a roadway to a Super 2 highway in 2020 on some random route between mile markers 468 and 468.5. Mostly because that's the only Google image we could find. but if you have those two different mile points, we're going to look at how many crashes occurred within those limits. So we went to, or we could have gone to CRIS, our crash information system, and this tells us in the last 5 years, yes, we had 1 head-on fatal crash, 3 sideswiping capacity injuries, et cetera. Overall, what we found is on average over those last 5 years, we had an annual average of 2 for fatal and serious injuries within the project limits. We then had to look at how could those average annual 2 crashes increase moving forward. So we looked at your traffic volumes. We're going to assume that's going to grow comparatively to traffic. So we took results from Rhino. So you have both your current and your design year forecast. So we have estimates for traffic volumes in 2035 as well as 2016 was made. We calculate what the annual geometric growth rate in traffic volumes is. We then applied that average annual geometric growth rate to the average annual crashes each year. You can see they grow by 2% every year over time. We're looking at both the no-build state. To get to the build state, we had to apply a crash modification factor. So we looked up TXDOT's definition for what the expected benefit of a Super 2 is from the Crash Modification Clearinghouse, which has all of them nationally, but this one's specific to TXDOT. And what their studies have shown is that if you build a Super 2, you're likely going to modify your crash total by 0.65. That essentially means a 35% reduction in fatal and serious injury crashes within the project limits when we do a Super 2. If our project's been indicated to be let in 2020, we're going to assume it'll be built then, so there's no change from the no build to build before the project's implemented. Once the project's implemented, we apply the crash modification factor. Now we have a new crash total, which will grow geometrically. Add up those columns, take the difference, and what we find is that if you build then a Super 2 for this example project, you would likely reduce your fatal and serious injuries by level 5 to 6 crashes. That then goes into decision lines to be scored. So now we have a raw performance rating associated with this project. We need to score on a level playing field. So we're going to apply that scaling concept. So if we looked at all of the projects, we ran this analysis, we found the best project possible could reduce 10 fatal serious injury crashes. This one reduces it by 5.63. If we linearly interpolate, that would tell us then this project would get about 0.563 of that overall score. So that'd be a rating for how well a project performs against this criterion. Questions on that? Once you have the scaled rating, we then need to incorporate the weight, which is the relative importance of that criterion to the overall decision process. In decision lines, you'll see 2 types of criterion weights, both local and global. Local referring to the overall importance relative to that overarching goal area. So within safety, this metric is considered to be 75% of that overall safety score. If you want to look globally against all performance areas, we would look at that overall weight, and this would tell us then that it would be about 37.5% of all possible scores. So the overall contribution to project score and then project score within safety. To get the score, you then just multiply the weights times that scaled rating, and you get a score component. And then all the score components would be added up across the criteria to give you that overall score. Questions on that? Okay, I'll take that as a good sign. How this relates to performance reporting. So the idea of this scoring process is to help us guide us to what are the most critical projects to fund. But ultimately what matters is what are we buying for our Texas residents and visitors. And so we want to understand the performance implications, and the way we do that is we add up all the different individual raw performance metrics. And so decision lines, you're going to see a differentiation between a rating and a metric. A rating is used to come up with a score. the metric is used for you to help set targets. So say if you fund this project, you would reduce fatal and serious injuries by a little over 5, and then if I fund multiple other types of projects, I add those up, that tell me the entire program would have this overall impact on safety. And you can compare that to a statewide no-build number if you want to set, say, a statewide target or regional number as well. I like this slide. Any questions before a break? You can bother me during the break if you'd like. Oh, there's one.
So you're able to configure bundled projects and capture the benefits as opposed to maybe individuals over time? So let's say if you have 2 projects, would it be more beneficial to capture them?
Yes. So the question is basically, can you bundle together multiple projects? Do you analyze them individually? So in decisions, there's a couple ways to do that. I believe they call it alternatives, which I probably should have been using. Alternative meaning more general phrase in case you want to be looking at programmatic investment levels, projects, corridor funding levels. Whatever you want to call that alternative, you can assign a benefit to. So you can combine projects as long as we understand the project limits, those geometries, so you can find the impacts within them and add them up. Or you can keep them separate and you can establish a dependency between them. So if you say this project will only get funded if I also do this one, I think there's an and dependency in decision lens, and I would say fund both or neither, and then would add up those metrics together. So you could do a mega project, or you keep them separate with a dependency, tell them that they're likely going to go together. You have that option. Does that answer your?
Yes.
Okay.
And can you build in a time component into that?
That is probably more Sanjay's side. So time-based dependencies, do you want to touch on that?
That's something that's upcoming release in about 3 weeks or so. We'll have that capability to do have to end by a certain date or start after a certain date, and also sequence between 2 projects. If this project has to end at the same time as another project, or this project can't start until this other project is done.
So there.
If we don't, we're going to get into it at the very end of the day where the dependency piece is. If I don't remember, remind me and I'll show you where it is so that you see what's there today and then what you should expect to see there in 3 weeks. That way you know where it is when you're looking at it.
So there's certain controls in there now where you can lock it in and say it has to be done this year or not. Maybe you can float around the time horizon. There are other tricks you can do, but yeah, the time base will allow you to then say this project is the second phase of a previous one. They have to go together, be a certain amount of distance apart. Can't start before this time, etc.
Great. That was, no, you know, he has the toughest job here this morning because everything he just covered is probably the guts and bolts of this tool, the most important, but it's always, you know, it's a task to try to, you know, explain that, so you did a great job, appreciate that. Let's take about a 15-minute break, and then we'll get started in about 10:20.